Welcome back. We're now in Lesson 5. This is Blackboard Video 5B for Math 127. Again, I'm Joe Cooper-Sannon, and today's lesson is all about observational studies. Okay, so Lesson 5, observational studies. In statistics, we're always interested in the whole group, right? The population, we would call it. Here's a massive crowd of people. So we're always interested in the whole group. We call that officially the population. And usually populations are large, so it's really going to be impractical to sample every person here in this crowd or every student at Cecil College, every person that lives in Maryland, for example. So what we do, we take samples, okay? Summary numbers that describe a population are called parameters. And for this crowd here, pictured, maybe we're interested in the average age of all the people in this crowd. But it would be nearly impossible to ask everybody how old you are. Okay? Impractical. A lot of times also it's unnecessary. Okay? Population's the big group. What we're going to concentrate on is taking good samples. So the solution in statistics, look at part of the whole. We'll call that a sample, as I said. And summary numbers that describe a sample. They're not called parameters here, they're called statistics. Okay. There's a graphic here on the slide. I have the population of Massachusetts. I looked it up on the internet. There's about 6 million people that live up in Massachusetts. And suppose that the variable of interest is diastolic blood pressure. We would never know that the mean is 78 millimeters of mercury for all 6 million people here. But the idea is, let's take a sample. What we need to understand is that if I take a sample, here's a sample of, I don't know, 30 people or so, the sample mean, their diastolic blood pressure is 75 millimeters of mercury. If I took another sample, that number is going to change. I'm trying to zero in for the population. It's 78 millimeters of mercury. But I'll never get to ask all these people. Take a separate sample. Here's a smaller one. You can see that the mean has changed. It's only 67 here. Take a third sample. You can see that the mean has changed. Here it's 71.3. One of the things that we deal with in statistics is this sample-to-sample variation exists. And what we need to do is learn how to deal with it, learn how to manage it, and even use it to our advantage. All right. We'll get out of Massachusetts. I think I have an example from Cecil College here, and you might recognize this building. It's our physical education facility. A few years ago, Cecil College spent some money to refurbish this. The question maybe administrators are asking, are students using the gym? Okay. What I'd like to do on the sideboard in just a second is draw a picture of population versus sample. Say that administrators are asking this question. Do you regularly use the phys ed building for any purpose besides your normally scheduled classes? Okay, so the school spent lots of money refurbishing this building. We'd like to know our students using it. We'll go over here to the sideboard. What I'd like to draw is a picture of the population and then draw a picture of the sample and see what that looks like. All right. Big circle for population. We'll label that as such. And there are some characteristics of this population. Namely, who lives in this population? It's all the students that go here at Cecil College. I'll call that capital N. We'll use capital N for population size. And it's hard to get the exact number, but our best guess, all 2,500 plus Cecil College students. When we're wondering if students are using the gym or not, this is the group that we care about. Okay, but it's really hard to email every student, text every student, find them in the parking lot with a clipboard and ask them, are they using the gym? Okay, so what do we do? In statistics, well, smaller circle here. That'll be our sample. We'll label it as such. And sample size is lowercase n. It's important to get those right. So sample size for whatever reason, the budget was 200 students. That's what we decided on. We'll collect data from 200 students. These students will use the information contained in the sample to address questions about the population. Okay? Now, we learned about parameter and statistic. Parameters are numbers that describe a population. So, the question we're asking, do you regularly use the gym? One way we could summarize that is with the proportion. I'll call that lowercase p over here. And over here would be the percentage of all Cecil students using the gym. Okay? Now that's a parameter, p. It's the percentage of all Cecil students using the gym. This number, the value of this number, is hard to get at. I would have to actually ask every student that goes here at Cecil College, do you use the gym? Okay? We go to our sample, we collect our data, we use the techniques we're going to learn about in lesson 5. And the symbol over here for that percentage or proportion is p with a caret on top. It's called p hat. And we'll have that data. I'm just going to make up numbers. We really didn't do this. So out of our 200 students, let's say 60 of them said, yes, I do use the gym to work out. As a percentage, that's about 30%. This number is a statistic. Statistics go with sample. They both actually start with the letter S. The number we most care about is a parameter. P for parameter, P for population. I'd like to write a couple notes about these numbers down. Okay. Number one, this number P, let's see where we can squeeze this in. P is unknown. Unless we truly asked every student that goes here, do you use the gym or don't you, we'll never really know the true value of P. Another word we can use to characterize P, P is fixed, or possibly constant, if you choose that word. What that means is at this time, there's a certain number of students that use the gym, and there's a certain number that don't. And if we had that information, which we'll never get, this number is a number. It's an unknown fixed number. It's not changing at this moment in time. Okay? Now, go to the sample, p hat here. That was the 30%. This came from the data that we collected. What would happen if I threw back those 200 students and sampled 200 more? Would I get 60 every time? Would I get 60 out of 200? 30% using the gym? And common sense tells me no. Different students use the gym, this number would certainly change. So a couple facts about p hat here. P hat changes from sample to sample. Now think to yourself, how many samples are we going to take? The answer is one. You're going to plan a study. You're interested in the population of all students. You'll collect your data. And whatever the data tells you, this is the information that you have to live with. You're not going to throw these students back. You're not going to collect a new sample. Okay, so this number would change from sample to sample, but we only take one sample. That's the data. Okay? If somebody said, what's your best guess? For the whole college, can you give me your best guess as to what percentage of students use the gym? The answer is we go to our data. Okay? In statistics, we take our sample information and we try to make decisions about a whole population. Okay? So, p hat is our best guess for P. I can squeeze it up here. P hat is our best guess for P. Now the terminology or the symbols are a little confusing. We've got to make sure this is that sample proportion, and I'm trying to estimate the population proportion. Okay, this would be my best guess. Do we know that 30% of all students use the gym at Cecil College? The answer is certainly probably not, unless we got really, really lucky. But it's probably close, right? I mean, I'd be really surprised if truly 70% of all students use the gym at Cecil College, because that's so inconsistent with what the data's telling me here. Okay? So, lots of big ideas in this picture here. Make sure we understand population is the big group. Parameters are numbers that describe a population. In statistics, we'll take a sample. Sample is going to be a piece of the population, usually much smaller. And these are statistics. These are numbers that describe the sample. What we're working towards in this class is what's called statistical inference. We use the information contained in the sample to make decisions and conclusions about the population. Okay, so this video ends here. Where we're heading in lesson 5 is, how do I collect a good sample? How can I pick 200 students that represent the whole group of 2,500 students? Okay, thanks.